Good afternoon, friends. Welcome you all to the next lecture of the JC E-Connect series of online lectures. Today we are into our third lecture of losses in pre-stress. In the first two lectures, we have seen the first three factors which cause losses of pre-stress, and we have also seen some numericals to find the exact impact of those losses or the factors which are causing those losses. Now, in today's lecture, let us continue with the further factors. The next factor is loss due to creep of concrete. Now, firstly, we should understand what is creep. Creep is a property of the concrete by the virtue of which it undergoes continuous deformation with time under sustained loading. Means creep is a time bound phenomenon which continues as the loading continuously takes place on the member. The total magnitude of the loss of pre-stress due to creep may be even larger than that due to the elastic deformation. Hence, the creep factor has to be considered and given due weightage while calculating the losses in pre-stress. The strain due to creep varies with the magnitude of stress. It is time dependent. Creep of concrete results in loss in steel stress. So the loss can be calculated by using two methods. One is the ultimate creep strain method, in which we find the losses by using the relation epsilon Cs into Es into Fc, where epsilon Cs is the ultimate creep strain, Es is the modulus of elasticity of steel, and Fc is the pre-stressing force in concrete at the level of steel. Or even we can use the creep coefficient method, in which the total loss is given by phi into m into Fc, where phi is the creep coefficient which varies between 1.5 to 4. It depends on various conditions such as the temperature, humidity, etc. It is given in IS 1343 1980 code book, page number 17. So you can either apply the previous method or creep coefficient method depending on what is asked and what is the given data. There will be a bit of variation in between both the answers. So moving further, next loss is the friction loss. So we have studied what is friction, and always friction force is the one which is an opposing force. So here also, in case of pre-stress concrete, because of friction we tend to lose the applied pre-stressing force. This type of loss occurs only in post-tension membered. In pre-tension membered, this type of loss does not occur. Now here the loss can take place at 2 points. The first is the loss in the jacking equipment, the equipment which you are using to transfer pre-stress. In that the friction loss can take place, but it is having a very small magnitude. So generally we can neglect it. But the loss which happens because of the friction of the tendons with the surrounding material is a considerable one. So it happens in two types. One is over a straight length where the tendons tend to wobble, that is, say, a vertical movement of type. Second is at the curvatures where the friction is caused due to the curvature as well as the wobble effect. So when we are placing the tendons and they start acting as per their shape, once they come into contact with the neighboring surfaces, they tend to undergo friction, which produces the frictional losses in post-tension members. The loss is given by the relation Px is equal to P naught into e raised to minus mu A plus Kx, where Px is the pre-stressing force at a section which is at a length x from the end considered. P naught is the pre-stressing force applied at the jacking end, or we can say the initial pre-stressing force. Mu is the coefficient of friction between the cable and the surrounding material, that is the duct, which varies between 0.25 and 0.55. Alpha is the cumulative angle in radians. It depends on the profile of the cable. K is the coefficient of friction for wave effect. Okay, that is the wobbling effect. E value is taken as 2.7183. Okay, so substituting the values, we can get the loss in pre-stress at particular section X. Further, if the values are very low or very small values of the curvature and all, we can directly apply the formula Px is equal to P naught into bracket 1 minus bracket mu alpha plus K into X, where if we expand the bracket, one term becomes P naught into 1 is P naught, other term is P naught into bracket mu alpha plus Kx, that is the loss in pre-stressing force which is occurring because of friction. So frictional losses are very important, and the initial loss because of jacking effect and all can be avoided by taking necessary precautions on the site. Next, loss due to anchorage slip. This is the basic loss which happens while transferring of the pre-stressing force from the jacking equipment to the tendons. During this, what happens is, during the release of the force, during the transfer stage, the wires slip over a small length or small distance before they are finally placed in the exact position. So because of this, a loss happens which is termed as loss due to anchorage slip. This is a loss which is most common and is bound to happen, but still we can reduce the amount of loss by taking necessary precautions during execution. The magnitude of this loss is given by the relation delta is equal to slip of anchorage multiplied by elasticity of modulus of elasticity of steel divided by the length of the cable. So percentage of this type of loss is higher when the length of the member is shorter, whereas this loss is considerably lower for high span members. So with this we complete the discussion of different types of losses or different types of causes which cause the loss of pre-stress in PSC members. So let's discuss one simple example for accounting loss due to creep. So in the given example, we have a section of size 100 by 300 and is pre-stressed by 5 wires of 7 mm diameter and located at eccentricity of 50 mm. So E is given as 50. The beam is of the size 100 by 300. There are 5 wires of 7 mm diameter. The initial pre-stress in wires is given as 1200 Newton per mm square. We have to find the losses in stress due to creep of concrete by using both the methods which we have discussed earlier today. So let's take down the given data, that is elasticity value of modulus of elasticity of steel and concrete. If not given, it has to be taken suitably. Let's calculate I, which is BD cube by 12. Then area is 300 into 100. Then epsilon cc is 41 into 10 raised to minus 6 mm per Newton per mm square. P, let us calculate, because the value is given in the form of stress, which has to be converted to newtons or kilonewtons. Then alpha or mu, which is the modular ratio, is the ratio of ES by EC, which we get as 6. The coefficient of creep is we are taking as 1.6. So applying the stress formula, P by A plus PE by I into E, we get the stress as 10.2 Newton per mm square. Therefore, the loss happening is equal to epsilon Cc into Fc into Es. So, substituting the values, we get the loss of 88 Newton per mm square. That is, for the applied pre-stress of 1200 Newton per mm square, we are encountering a loss of 88 Newton per mm square. This is by ultimate creep strain method. Now next, using creep coefficient method, loss is calculated by substituting the values, and we get the loss as 97.92 Newton per mm square. Hence, we here find that the loss which we got when we analyze using creep coefficient method is greater than the loss which we got by the other method. So this is just a small example to make you all understand the effect of creep. Hopefully you are going through all the videos, making the notes. Again, I am requesting you all, if you have any queries, anything to discuss, please text or call. Secondly, the assignments which were previously given, the answers were posted. Please check if you have got the answers correctly, and again I am repeating, once when the college starts, these assignments will be checked. So please, on daily basis, complete the routine works. Don't take it as a vacation, because once the college starts, things will move very much rapidly. So in tomorrow's class, we'll start with further examples covering the different losses in pre-stress concrete. Thank you. Have a nice day.